Scripting, important classes. The section provides an overview of some of the most commonly used and important built-in classes in Unity that you may want to use when scripting. These pages serve as a starting point for the discovery of scripting basics in Unity and do not cover all classes in Unity or even every member of the class which are covered. For a complete reference, you can check out this link, the script reference, and mainly we're going to have the game object that represents the type of objects which can exist in a scene, the mono behavior, the base class from which every Unity script derives by default, object, the base class for all objects that Unity can reference in the editor, transform, provides you with a variety of ways to work with a game object's position, rotation, and scale via script, as well as its hierarchical relationship to parent and child game objects, vectors, classes for expressing and manipulating 2D, 3D, and 4D points, lines, and directions, quaternion, a class which represents an absolute or relative rotation and provides methods for creating and manipulating them. Now we have the scriptable object, a data container that you can use to save large amounts of data, time, and frame rate management. The time class allows you to measure and control time and manage the frame rate of your project. Math function, a collection of common math functions including trigonometric, logarithmic, and other functions commonly required in games and app development. Random provides you with easy ways of generating various commonly required types of random values. Debug allows you to visualize information in the editor that may help you understand or investigate what's going on in your project while it is running. And finally, we have gizmos and handles, allows you to draw lines and shapes in the scene view and game view, as well as interactive handles and controls. So if you go into the Visual Studio, into the Unity Hub, and from here you can just grab the project that you've been working on it, or just create a new project altogether. Just go here and then create a 2D or 3D project, 3D, and then just click create. So I already have one here. From right now we're gonna see the game object. So again, we are inside of the scripting, we are inside of important classes, and now we're gonna go into the game object. So let's just put here. If you can switch it up to scripting here. If we click this one, so this is the scripting. You can also switch it back to manual, so let's keep it in manual. So important classes, game object. So Unity's game object class represents anything which can exist in a scene. Okay, so let's move this one here, and pretty much this is the scene and this is the game. We have right now this playing here, so it's pretty much doing nothing, it's just sitting there. And I have some C# scripts from the previous video. Okay, so this page relates to scripting with Unity's GameObject class. To learn about using game objects and the scene and hierarchy and the Unity editor, see the GameObject section of the user manual for an exhaustive reference of every member of the GameObject class. See the GameObject script reference. Game objects are the building blocks for scenes in Unity and act as a container for functional components which determine how the game object looks and what the game object does. In scripting, the game object class provides a collection of methods which allows you to work with them and your code, including finding, making connections, and sending messages between game objects, and adding or removing components attached to the game object, and setting values relating to their status within the scene. So let's check out the scene status property. Okay, so here they're dealing with the inspector. So if we go, I don't know, maybe into this plane here. Okay, so and I click this little button, the view tool. This is the move tool, this is the rotate tool, this is the scale tool. Okay, if you want to make this one bigger, smaller, so you can scale it. And pretty much I'm doing it right now in the X position, this would be in the Z position, and also in the Y position. Oops, well, not in the Y position, and this is just a plane. This is the rectangular tool, so let me see. Okay, just like that, rectangular. And the transform tool, so Okay, so this is the transform tool. As you can see, I can play around with this. And let me check out the camera. So where is the camera? Let me go into the camera and no, I need to grab this one, move tool, camera, and let me see. Yeah, so this is the plane. Okay, and the camera is not pretty much. Let's just rotate the camera as well. Oops, no. Yeah, let's just rotate the camera as well. So okay, so now I can see this one, yeah, that would be the plane. So let me see, plane. Okay, so we have that so far, but let's keep moving. So the scene status property, you can use scripts to modify many properties related to a game object's status in the scene. These typically correspond to the controls visible near the top of the inspector when you have a game object selected in the editor. They don't relate to any particular component and are visible in the inspector of a game object at the top above the list of components. So again, if we go into the inspector, here we have I selected the main camera, now I selected the plane, now the main camera, now the plane. So we can make this one bigger, so I can pretty much have it like this. Okay, so the layer is default, tag is untag, then we have the transform, the planes on mesh collider. So here, directional light, and this is static, so let me check out directional blah blah blah, untag. Okay, so we can pretty much also choose the directional tag, the directional light. So let me move this one back here, and now let me see if I select the directional light, and I'm just gonna grab this one. So this is the directional light. This is pretty much what we are seeing right now. Let me see if I delete this one, and okay, yeah, it was that, the directional line. Okay, so I delete it, and I press just Ctrl Z, and I am able to see. So this is okay, so this is kind of the light, but I don't know, maybe you can think of like the moon. Okay, so yeah, looks kind of cool. Let me see the camera. This is the camera, main camera, and let's just keep moving it around. So let me see. Okay, so this is pretty much, you can play around here. I can see just that light. Let me see also the plane, so like that maybe. So oops, yeah, let me see. No, it doesn't appear here. Okay, I can see the plane so far. Oops, yeah, I was here. Yeah, something like that, so kind of like a UFO type of thing, maybe. Okay, so a typical game object view and the inspector, in this case a directional light. The scene status properties are outlined in red, so pretty much this is the scene status property, the tag, the layer, the directional light, and here the static is unchecked. So let me see in mine. Yeah, the static is unchecked, the tag is untagged, and the layer is default. So yeah, everything is cool here. So all game objects share a set of controls at the top of the inspector relating to the game object's status within the scene, and this can be controlled via the GameObject scripting API. If you want a quick list of all available API for the GameObject class, see the GameObject script reference, so you can check out this link. Okay, now active status. So here they give us, this is checked, so in mine, mine is checked, the directional light, everything is fine. An active status of a game object. Game objects are active by default but can be deactivated, which turns off all components attached to the game object. This generally means it will become invisible and not receive any of the normal callbacks or events such as update or fix update. The game object's active status is represented by the checkbox to the left of the game's object's name. You can control this using the game object that's set active. So to pretty much, as they say here, the game object's active status is represented by the checkbox to the left of the game object's name. So in our case, if I go into the scene, if I go into this one, and just gonna press the move tool, so I'm gonna uncheck it. So I'm gonna check it now. Now everything is working fine. Okay, let me see. Okay, so now okay, here the game objects, let me see, active status. Okay, game objects are active by default but can be deactivated. Okay, so we already did that. The game object's active status is represented by the checkbox to the left. Okay, you can also use the game object that active self to read the current active state of the game object. Use the game object that active hierarchy, or pretty much the game object that active in hierarchy, to read whether the game object is actually active in the scene. Game object that active in hierarchy is necessary because whether a game object is actually active is determined by its own active state and the active state of all its parents. If any of its parents are inactive, then it's not active despite its own active setting. So for example, let's say well, I have three game game objects. So we have here the main camera, the directional light, and the plane. So let's say these are in the same hierarchy, but now if I just move the plane inside of the directional light, so now pretty much the plane becomes dependent of the directional light, and the directional light becomes kind of like the parent, and this is the child. Okay, so this is the example. So now as I say here, it's necessary because whether the game object is actually active is determined by its own active state and the active state of all its parents. So if any of its parents are inactive, then it's not active despite its own setting. So in this case, for example, maybe if I take this one out and now I move the directional light inside of the plane, so now the directional light becomes depending of the plane. So let's say the directional light is checked, but now let's go to the plane. The plane is also checked, but now let's uncheck it. So this time it will work because here, if any of its parents are inactive, then it's not active despite its own active setting. So that's that. We can leave it like that. We can check it again and just move this one here so the three are in the same level or in the same hierarchy. And what happened here? Oh, okay, so I was just playing around, messing around here. Oops, yeah, I was just having a good time here. Okay, so we still see in the moon. That's the main camera. Okay, oops, let me see, what is the, oops, yeah, now I can see the moon from below, maybe kind of like an astronaut. Okay, so let's keep moving. Now, some of Unity systems such as the global illumination, occlusion, batching, navigation, and reflection probes rely on the static status of a game object. You can control which of Unity systems consider the game object to be static by using the GameObject utility that set static editors flags. Read more about the static game objects here, so you can check out that. Now we have the tags and layers. Again, if we go into the scene and just go into, let's add another 3D object, maybe a cube. Okay, so we added a cube here, and let's just take out this plane, maybe also the, let me put it like that. And okay, so we're gonna, yeah, we can just leave it like that. We can just go into the cube right now and go into here we see the tag and we can see the layer. The tag is untag and the layer is set default. Okay, so the tag and layer fields of a game object. Tags provide a way of marking and identifying types of game objects, and you're seeing, and layers provide a similar but distinct way of including or excluding groups of game objects from certain built-in actions, such as rendering or physics collisions. For more information on how to use that, you can check out the tags and layers. You can modify tags and layers value via the script using the GameObject.tag and the GameObject.layer properties. You can also check a GameObject tag efficiently by using the compareTag method, which includes validation of whether the tag exists and doesn't cause any memory allocation. And then we have adding and removing components, accessing components. So let me see, accessing components on other game objects, finding child game objects, sending and broadcasting messages, finding game objects by name or tag, and creating and destroying game objects. Okay, so we also have the primitives. Okay, let me see, let's check out here the primitives. The GameObject class offers script-based alternatives to the options available in Unity's GameObject menu that allows you to create primitive objects. To create instances of Unity's built-in primitives, use GameObject that create primitive, which instantiates a primitive of the type that you specify. The available primitive types are the sphere, the capsule, cylinder, cube, plane, quad. And also you can pretty much export 3D models from something like a software, kind of like a Blender, for example. Okay, so we have that. And let me see, adding and removing components. So you can add or remove components at runtime, which can be useful for procedural creating game objects or modifying how a game object behaves. Know that you can also enable or disable script components in some types of built-in component via script without destroying them. The best way to add a component at runtime is to use the add component, specifying the type of component within the angle brackets as shown. To remove a component, you must use the object.destroy method on the component itself. Now, accessing components. The simplest case is where a script on a game object needs to access another component attached to the same object, to the same game object. Remember, other scripts attached to a game object are also components themselves. To do this, the first step is to get a reference to the component instance you want to work with. This is done with the getComponent method. Typically, you want to assign the component object to a variable, which is done and using the following code. In this example, the script is getting a reference to a rigid body component on the same object, on the same game object. So we have the void star. So inside of the curly braces, we have the rigid body RB set to the get component, and then we have the rigid body. Now, once you have a reference to a component instance, you can set the values of its properties match as you would in the inspector. So we have the void star rigid body RB set to the component rigid body. Then we have the RB that must set to 10 feet. You can also call methods on the component reference, for example. So you have the rigid body RB set to the get component rigid body, and then we have the RB that add force vector 3 that up multiplied by 10 feet. So we have that. Then we have the accessing components on other game objects, linking game object with the variables in the inspector. So we will have with the most straightforward way to find a related game object is to add a public game object variable to the script. So we have the public class chef, mono behavior, public game object stuff, and then here other variables and functions. Now, this variable will be visible in the inspector as a game object field. You can now drag an object from the scene hierarchy panel into this variable and assign it. So again, like in the assets, for example, I have here in the free fab, I have the scenes and I have the script. So you can just pretty much, for example, just drag here. You can drag it and drop it here. And in this case, for example, let me see if I go into the cube. I don't have it here, but let me see if I just, I don't know, let me see, I'm gonna grab this wall script. So this is from the previous video, but I'm just gonna drop it here in the cube. So now the cube has a script. So now has a block, and the block is GameObject, so it's nothing. Now I'm just gonna grab this cube and just gonna drop it here. Now the block is gonna be the cube, this one. So again, nothing is gonna change because I believe the camera is not in the right position, but just let's give it a try. So and see, I mean, it's working because I can see a bunch of clones here of the black, but the camera is not in a, okay, as you can see here, but the camera is not pointing at them. So let me see if I can fix that real quick on the fly. So okay, so you can kind of have an idea here. Let me see. Oops. Let me see. Okay, so I have that, and let me move this one maybe closer, and this one would be like that, something like this. Okay, so I have this example here. So pretty much you grab it from the a file from the assets, and you just pretty much drop it into here. In this case they're showing you the instantiate example in the script, but I drop it into the, let me see, it was let me see, it was okay, no, this is the cube. It was in the black, so it was here, and by default it's gonna be set to the, well, by default it's gonna be set to none, but now I just drop the black. I can also drop a capsule, a sphere, all those primitives that we were seeing. So dragging a prefab from a project window into a GameObject field and the inspector window. So that's that. Yeah, these are the primitive objects. So you have the plane, the cube with the sphere, the capsule, and yeah, this is, yeah, and also we have this, what's it, the cylinder. And yeah, pretty much this is all that we have for the important classes GameObject.